Hello students, welcome back to our channel Maths by SRAVAN. Hope you all doing well, and if you are watching our channel first time, do subscribe to our channel. In this video lecture, we are going to discuss about correlation. So name itself says the meaning. Correlation. It is a statistical analysis to know the relation between two variables, how they fluctuate. The change in one variable, how reflects the another. It is a statistical analysis which discuss about the relation between two variables. The relation between two or more variables. A statistical analysis which describes about two or more variables, how they fluctuate, how they change with change of another. That we will discuss in correlation. There are so many types of correlations. There are so many types of correlation. The first one, positive negative correlation. Positive and negative correlation. Similarly, simple and multiple correlation. Multiple. Partial and total. Partial and total correlation. Linear and non-linear correlation. These are all types of correlation. The basic criteria behind these all types of correlation is a relation between two or more variables. How they analyze. Coming to positive and negative, here the positive correlation, negative correlation. Positive correlation, we say that two variables are positively correlated if the change of one variable changes another in the same direction. Basing on direction, how they are changing, increase or decrease. What I am saying, if x increases, y also increases. If x decreases, y also decreases. If the change in two variables is in same direction, then that correlation we will call it as positive correlation. So we can easily imagine what is negative correlation. The change in one variable shows like that. The direction is in opposite direction. If x increases, y decreases. X decreases, y increases. Then we say that x and y are negatively correlated. Basing on the direction of the variability, how they change, we will describe positive and negative correlation. If the change is in same direction, then we say they are in positively correlated. If the change is in opposite direction, we say they are negatively correlated. Coming to simple and multiple correlation. Simple and multiple. So name itself says meaning. This simple correlation studies about the relation between two variables only. How two variables changes. Here I had given one example for positive and negative by taking two variables. That we can call it as simple correlation, one type of simple correlation. The study of relation between variability between two variables indicates simple correlation, multiple more than two. If you want to study the relation between more than two variables, we prefer multiple correlation. More than two, not exactly two. If we study the relation between two variables, how one variable varies depending on another, then we call that one as simple. If there are more than two variables, we call that one as multiple correlation. Coming to partial and total. Total correlation and partial correlation. Partial correlation, total correlation. So partial correlation means study of two variables excluding some other variables. You are studying more than two variables like multiple, but excluding few variables. If you consider only two variables, if you see the relation between only two, we call that one as partial correlation. Studying two, studying few, excluding another, excluding other. Studying about all, studying about all the variables. In one criteria, we may have more than two or three variables. For example, if you take a bachelor degree, in that they may have languages and group subjects. While coming to the percentage to decide whether student got first class or second class or distinction, they excludes languages. They may have languages 40%, 50%, but they won't consider that 40-50. If a student has scored more than 60 or equal to 60, they consider first class only in groups, group subjects. Maths, physics, chemistry, if they score 60 or more than 60, they will consider he is first class. They ignore the languages. But coming to decide whether the student is pass or fail, they will consider all the subjects. He has to score minimum 40% in all subjects, including languages. But to see the percentage or class, to give the class, they will consider only group. So to give the class, first class or second class or distinction, they prefer partial correlation. In the case of pass or fail student results, they consider all. So like this, we will study the difference between a relation between some variables. That is one example. So coming to linear and non-linear. So here, linear and non-linear. So linear, the relation between two or more variables is uniform. They are varying, but in one direction, in particular way, in particular order, uniformly they are varying. Then we say that correlation is linear correlation. If it is not in uniform way, one variable varying in one direction, not in same direction, not in unique way, then we say that that correlation is non-linear correlation. Next we will discuss how to study the correlation. What are the methods of studying correlation? In what way we are going to evaluate correlation coefficient? These all we will discuss the study of correlation. Okay, are you clear what is correlation, types of correlation? Methods of studying correlation. How we are going to find correlation? Correlation means how the two variables related, how they have relation by means of one value. Basing on one value, how we can decide mathematically, how we can study the relation between correlation, how we can analyze the relation. That we are going to discuss in methods of studying correlation. Broadly, there are two methods to study the correlation. One is graphical method. Another one is mathematical methods. Two methods are there. Coming to graphical method, again in this we have two more methods. One is scatter diagram method using simple graphs. Simple graphs and scatter diagrams. So coming to the graphical method. Graphical method, name itself says meaning, using some graphs. The graphs will be classified into two types: scatter diagrams, simple graphs. If we discuss about two variables, while discussing about two variables, simple correlation, that two variables, if you assume x variable and y variable, these two variables are plotted using two lines. They are horizontal line and vertical line. X variables are in horizontal line, y variables will be in vertical line, like x-axis and y-axis. Instead of saying x and y-axis, here we call this one as horizontal line and vertical line. In this, we will draw the figure. Basing on that figure, that diagram, we are going to decide how the two variables are related. For example, if you get graph like this, we say they are perfect positively correlated. Positive correlation. If you get the figure like this, then we say they are perfect negative correlation they have. So partial positive correlation like this, if you get graph like this is also negative. That is perfect positive, that one is perfect negative. Here higher degree positive correlation, this is higher degree positive correlation, this is higher degree negative, this is perfect negative correlation. Like this, by seeing the graph itself, one can easily decide the correlation between the two. For example, after drawing a scatter diagram, you got a graph like this. You get a graph like this. You cannot say anything about the relation. That means no correlation. So like this, one can easily decide how the two variables are related using scatter diagrams. Coming to the simple graphs, by taking a graph paper, on graph paper, by taking x-axis and y-axis, you are going to plot the points. You will join the points by a smooth curve. Basing on that smooth curve, you can decide whether they are related positively or negatively. That means what I am saying, if you draw the two variables on graph, if they are parallel, we can say they are positively related. They move in same direction. We say the two variables related positively. They move in opposite direction. We say the two variables are related negatively. By taking graph paper, this you generally do in your labs. While doing some experiment, you will take graph. You will draw the graph between two variables. You will find out how they are related. That relation, knowingly or unknowingly, we are doing on graph paper in so many labs. Now coming to the mathematical methods, which we are going to discuss in detail in correlation. So here we are going to discuss few methods Few, there are so many, few we are going to discuss. One is Carl Pearson's coefficient of correlation. Coefficient of correlation, Carl Pearson's. Spearman's rank correlation coefficient. Rank correlation coefficient. And the method of least squares. Like this, so many methods we are having. So that comes under regression also. So here we concentrate much on Carl Pearson's coefficient of correlation, Spearman's rank correlation coefficient. Carl Pearson's coefficient of correlation, we will discuss about two variables when some raw data is given. Some xy values are given. We will find out that relation between x and y with correlation coefficient. This correlation coefficient generally we represent by R, rank correlation coefficient rho. They lies between -1 and 1. Depending on R value, one can easily decide they are positively related or negatively related. That we will discuss in detail about Carl Pearson and Spearman rank. What is formula for R? What is formula for R? Rho? That we will discuss by taking one problem. We are going to find Carl Pearson's coefficient of correlation. This is our exact topic in correlation. Next we will discuss what is formula for calculating Carl Pearson's coefficient of correlation. How we are going to evaluate small r for given data. How we are going to evaluate rank correlation. Whenever ranks of the data is given, whenever if you want to find ranks of given x and y values, then we will find rank correlation. Generally, after examinations, after getting marks, we will give rank. Basing on that rank, we can find how the ranks are related. Rank correlation, that is, rank correlation coefficient. By evaluating ranks, we will decide how they are related. There is a problem we have, mathematics and statistics marks are given, find rank correlation coefficient for the two subjects. That we are going to calculate. First we will give ranks. For that ranks we are going to calculate rank correlation coefficient using rho formula. Okay, we will discuss in detail about one by one. Mathematical methods to find the correlation. How we are going to find correlation using mathematical methods. In that, the first one is Carl Pearson's coefficient of correlation. Carl Pearson's coefficient of correlation. So this is scientist name who invented this coefficient of correlation. Carl Pearson's coefficient of correlation, a British mathematician who invented coefficient of correlation here. What is called coefficient of correlation? So here, this coefficient of correlation studies the variability between two variables in linear variability. How the two variables vary when they are in first degree, x and y. That one we are going to calculate using Carl Pearson's coefficient of correlation. The magnitude of variability of the two variables, linear variables, we are going to evaluate using Carl Pearson's coefficient of correlation. It is denoted by small r. It is denoted by small r, and it has some. It can be evaluated using so many formulas. The best one among them is sigma xy by square root of sigma x square into sigma y square. There are so many formulas to find coefficient of correlation. So among this we use repeatedly this formula. There is another one also, covariance of x comma y by sigma x into sigma y. So there is one more formula. Like this, so many formulas we are having. Sigma xy by sigma x into sigma y. So like this one can evaluate coefficient of correlation using different formulas. But we prefer this one when series of numbers are given, where capital X we take sometimes as x minus x bar, capital Y is y minus y bar. Whenever capital XY values are large numbers, to make simple and to calculate easily. Here x bar is mean of x values, y bar is mean of y values, and also in the case sigma x is standard deviation of x values, sigma y is SD of y values. So these are so many formulas for R. We prefer this one to calculate coefficient of correlation. What are the properties of coefficient of correlation? So here R always lies between -1 and +1. This you need to keep in our mind. While calculating coefficient of correlation, that is Pearson's coefficient of correlation, the answer should be lies between -1 and 1. And if R is +1, they have positive correlation. They are related positively. You know what is positive correlation? The direction of variability is in same direction. If x increases, y increases. If R equal to -1, we say that they are negatively correlated. X increases, y decreases. Negative correlation. If R equal to 0, then uncorrelated. There is no correlation between x and y. So basing on this, we can describe the relation between x and y. We can easily say how they are related, positively related or negatively related, whether they are related or not, that means uncorrelated or not. We can evaluate using this formula, this technique. This is Pearson's coefficient of correlation. This point you need to remember in your mind. Very most important point. Find if there is any significant correlation between the heights and weights given below. We need to find any correlation between heights and weights. That means we need to find correlation coefficient. The formula to find correlation coefficient, small r equal to sigma xy by square root of sigma x square into sigma y square. So now we need to find these all values. For that, first you need to find x bar and y bar. So x bar is sum of x values. What we are assuming, heights in inches is taken as small x and weight is taken as y. And capital X is taken as x minus x bar, this value. Next we are going to find capital X square. Next, capital Y equal to y minus y bar we are going to evaluate. Next, capital Y square. Finally, capital X into capital Y. These values we are going to evaluate. After evaluating these all, we can find a correlation, smaller value. So heights given, 57, 59, 62, 63, 64, 65, 55, 58, 57. If you take grand total of these all, you will get 540. Similarly, y values 113. Y values are here. 113, 117, 126, 126, 130, 129, 111, 116, 112. So these grand total you will get 1080. So now 540 by the number of values, how many we are having, count 1, 2, 3, 4, 5, 6, 7, 8, 9. 540 by 4, 9 6 are 54. Similarly, 1080 by 9, 9 12 108, so 120. Now subtract every value of x from x bar. Subtract every value of x here. X minus x bar. 57 minus 60 minus 3. 59 minus 60 minus 1. 62 minus 62. 63 minus 63. 64 minus 64. 65 minus 65. 55 minus 60 minus 5. 58 minus 60 minus 2. 57 minus 60 minus 3. So this sum no need in the question. We need sigma xy and sigma x square and sigma y square. Next x square, this sigma needed 9, 1, 4, 9, 9, 1, 4, 9, 16, 25, 25, 4, 9. Find out this total. That is treated as sigma x square. This, use your calculator, you will get 102 sigma x square. Y. Y minus y bar. Subtract y values from there. 113 minus 120 minus 7. 117 minus 120 minus 3. 126 minus 120 6. 6. 130 minus 120 10. 129 9. 111 9 minus 9. 116 minus 4. 112 minus 8. Okay, these you need to find. Next, y square. 49 9 36 36 100 81 81 16 64. Square these all values. Y square. Now find out sigma y square that is needed. That you will get 472, the total value. Next, sigma xy. Multiply capital X and capital Y. These two. 7 3s are like that. Minus into minus plus. 3. 2 into 6. Again 3 into 6. 4 into 10. 5 into 9. Again 5 into 9. Next 2 into 4. 3 into 8. So these values you need to add, you will get 216. Now we have sigma x square value. Sigma x square 102. Sigma y square 472. Sigma xy 216. Using these values we are going to evaluate our sigma xy by square root of sigma x square into sigma y square. What is sigma xy? 216 by square root of 102 into 472. So our value will get 0.9 correlation between coefficient of correlation for the given data. Positive value. So 0.998. Use your calculator. You will get the finally answer, smaller answer. Okay. So 0.98. Are you clear? Any doubts? Preparing this table takes a little time. After preparing table, you will get the answer very easy. With the following data, in 6 cities, calculate the coefficient of correlation by Pearson's method between density and population, density of population and death rate. So here the data is given, cities, area in square kilometers is given, population in thousands. That means here you need to add 3 zeros, 30,000, 90,000, 40,000, 42,000. This is not just 30, this is 30,000, 90,000, like this. So number of deaths are given. So before going to find the relation between density of population and death rate, first of all you need to know what is the formula to calculate density of population and death rate. Density of population by area. 30,000 by 150 you need to do. Then you will get the population density for A city you will get. 30,000 by 150, 200, like that. 90,000 by 180, 40,000 by 100, 42,000 by 60, 72,000 by 120, 24,000 by 80. Like that you can calculate density. Next, death rate. Death rate. Death rate is number of deaths by population. Number of deaths by population. This value by this value, this value by this value. For our convenience, here 300 by 30 we will take. Small value we will get. 10, 300 by 30, 10 we will take. Here we will take in thousands. So that calculation will be easy. Now we are taking density of population with X, death rate with Y. Now we are going to calculate coefficient of correlation table. To calculate small r, we have formula sigma xy by square root of sigma x square into sigma y square, where capital X is x minus x bar, capital Y is y minus y bar. So these we need to find. Here small x minus x bar, small x is density of population, small y is death rate. Now taking small x and small y, density of population and death rate. So simply we can assume this one as density, this one as death rate. Next we need to find capital X, x minus x bar. Next capital X square, capital Y, small y minus y bar, capital Y square, capital X into capital Y. So these values we need to calculate. So to calculate these values, first calculate small x using this formula, population by area, 30,000 by 150 to avoid decimals. Okay, so that values we need to calculate. 200, 500, 90,000 by 180, next 40,000 by 100, clear, 400, 42,000 by 60 next, you will get 700, next 72,000 by 120, you will get 600, 44,000 by 80, you will get 300. Are you clear? The formula is very clear. Using that formula, we are going to evaluate. Next, coming to small y values. Number of deaths by population. 300 by 30. 10. 1440 by 90. You need to do. 16. 560 by 40. You need to do 14. 840 by 42. 20. Next, 1224 by 72,000, you will get 17. 312 by 24, 13. Now subtract. X minus x bar. Before that, we need to calculate x bar. That means we need to calculate these totals. Small x total, small y total. If you take this total 2700, if you take the density total, you will get 90. So 6 values, x bar will be 2700 by 60, y bar will be 90 by 6. 90 by 6, 15, you will get here 15, 2700 by 6, 450 you will get. Now subtract. 200 minus 450, what you will get? Minus 250. 500 minus 450, 50. 400 minus 450, minus 50. 700 minus 450, 250. 600 minus 450, 150. 300 minus 450, minus 150. Okay, like this you need to calculate. Next, x square. You need to square these values. X square, 25 square, 625. 625 double 0. 5 square, 25 double 0. 25 double 0. 25 square again. 625 double 0. Again, 15 square. 15 square, 225 double 0. 15 square, 225 double 0. 25 double 0. 225 double 0. Okay, like this you need to calculate x square. Next, you need to calculate the sum of capital X square, because we are going to use that one. 1,75,000. Capital Y. Y minus y bar. Y bar is 15. 10 minus 15, minus 5. 16 minus 15, 1. 14 minus 15, minus 1. 20 minus 15, 5. 17 minus 15, 2. 13 minus 15, minus 2. So like this, you need to calculate y minus y bar values. Next, y square. 25, 1, 1, 25, 4, 4. So add sigma y square values. You will get 60 here. Sigma y square. Sigma xy. Multiply x and y. Minus 250 into 5. So like that you need to multiply 1250. 50 into 1. 50. 50. 250 into 5. Again. 1250. 150 into 2. 300. 300. Okay. Now calculate total value. You will get here 3200. Sigma xy. Now we need to calculate coefficient of correlation, small r equal to sigma xy by square root of sigma x square into sigma y square. So this is sigma x square, sigma xy, sigma y square. So sigma xy is 3200 by 175,000 into 60. You will use your calculator. Use your calculator to get R. Okay. Like this, you need to prepare this table. Here, the difficulty is preparing table. If you can prepare the table, then easily you can find the correlation coefficient between given data.